an equation that have x is equal to or y is equal to, or basically a variable equal to some expression. Notice in the examples I gave you, that is not the case. So you're going to have to rewrite one of the equations. So the easiest one that you might see is the one in which a variable has a coefficient of 1, like the second one. So I'm going to put a star and say this is the one I think I'm going to try to rewrite so that it is x is equal to some expression. So let's do so. X minus 2y equals 11. And I'm going to solve for x. So now, if I want to solve for x, the opposite or the inverse is to add 2y. Now, by me adding 2y, I'm going to move this term to the right-hand side. Cancel out. And now I have x is equal to 2y plus 11. Perfect. That's what I want. So now when I try to start solving for my variables of x or y, I can now substitute this expression 2y plus 11 every time I see x. So let's do so. I'm going to write the first equation, negative 7x minus 2y equals negative 13. Okay? So now I'm going to plug in 2y plus 11 every time I see x. So negative 7 times 2x plus 11 minus 2y equals negative 13. Because I have substituted, and this is a mistake that I made, I need to make this into a y. Because I've substituted for my x, you need to know that you are now solving for y. Okay? So negative 7 times 2 gives me negative 14y. Negative 7 times 11 gives me negative 77. Minus 2y is equal to negative 13. Always check over your work to make sure you haven't made any careless mistakes. Negative 14 minus 2 is negative 16y. I combine it like terms. Bring down my negative 77, and it is equal to negative 13. Remember, you always want to isolate or get the term with the variable by itself. So you're going to move negative 77 by adding. Negative 16y is equal to 7 from 3 is 4. 1 from 7 is 6, so we're at 64. Okay? Well, I want to get y by itself, so the opposite or the inverse of multiplying by 16 would be to divide. Y is now equal to a negative 4. So I'm going to put up here in the solutions, negative 4 is my second number in the solution. But remember, I need to find x. So let's go back to the equation that we rewrote, which was x is now equal to 2y plus 11. It's in a format for me to find x. So now I'm going to write x is equal to, and where I see y, I'm now substituting it for negative 4. Because that's what we just found. So now 2 times negative 4 plus 11. X is equal to 2 times negative 4 is negative 8. Negative 8 plus 11 gives me x is equal to positive 3. So I am now saying my order pair, or my solution to this systems of equation, is positive 3, negative 4. That's my solution. But you know, all great mathematicians check their work. So we're going to erase really quickly. Negative 7x minus 2y equals negative 13. X minus 2y equals 11. We're going to plug in what we know. Negative 7 times 3 minus 2 times y, which is negative 4, equals negative 13. Negative 7 times 3 is negative 21. Negative 2 times negative 4 is positive 8. Negative 21 plus 8 is negative 13. And negative 13 equals negative 13. So far, the solution makes that equation true. The last one, x is positive 3 minus 2 times y, which is negative 4, is equal to 11. 3, now, negative 2 times 4 is a positive 8. 3 plus 8 is 11. 11 equals 11. So guess what? Our solution is correct because it makes both equations true. Hope you enjoy your lesson on systems of equation, solving systems of equation using the substitution method. Have a great day.